Hi all, we're going to talk about S3 triangle inequality. The triangle inequality will be like this. Assume that the triangles, the three sides are A, B, C respectively. So what the inequality we can have is A plus B is larger than C, B plus C is larger than A, C plus A is larger than B if the triangle can be formed. To understand more easily, just imagine if one of the sides of a triangle is extremely long, while the remaining two sides is relatively much shorter. If I add the two shorter sides, it's still less than or equals to the longer side. Can I form a triangle? It is impossible. It's just right here. The two red sides cannot even match with each other. How can I form a triangle? Right? So that's the conclusion. If the triangle can be formed, any sum of two sides must be larger than the remaining side. Okay? So the proof is very straightforward. Example 12. Determine whether the three line segments can form the triangle. What you need to do for every case, consider the shortest two sides, add them and check. Oh, larger than the longest side, so okay. Less than the longest side, bye bye. Equals to the longest side, bye bye. That is the proof. Determine. But how about the following? Is instant drill question 13. I'm going to do this. Now, how many different triangles can be formed with the triangle of length x cm, 2x cm, and 9 cm? Let me sketch the diagram out first. The triangle, just any. For example, this is x cm, this is 2x cm, and 9 cm. What can we do? We can form inequalities. Three different inequalities by triangle inequality. The first one, and remember, any sum of two sides will be longer than the remaining side. So for example, x plus 2x is larger than 9, 2x plus 9 is larger than x, 9 plus x is larger than 2x. We have three inequalities formed. Okay, we solve it one by one. For one, x plus 2x is larger than 9, 3x is larger than 9, so x is larger than 3. Okay, 2, 2x plus 9 is larger than x, so x is larger than negative 9. The second inequality. The third one, 9 plus x is larger than 2x, so 9 is larger than x, x is less than 9. Okay, now we have three inequalities formed. Now I'll teach you something more enrichment. It's something related to the graphical solution, compound inequalities. Now we have 1, 2, 3, these three different inequalities. Let's show them on the number line. Okay, so x is larger than 3, negative 9, and less than 9. So negative 9, for example, is here. This is 3. This is 9. Okay, somehow in this form. Larger than negative 9. Larger than 3. Less than 9. So for which region it satisfies these three inequalities? Well, for sure, must be this region only. Because this region is larger than negative 9, larger than 3, and less than 9. So what can we have? It's actually, also again, this is enrichment. So we can have, therefore, the solution will be between 3 to 9. Wow, x is an integer. So what can be the values of x? They can be 4, 5, 6, 7, 8, right? Only these 5. So therefore, how many different triangles can be formed? So we have 5 different triangles can be formed. Are you sure? Let's double check. Better to check it carefully. Now, for each x is 4, I have 4, 8, and 9. 5, 5, 10, and 9. 6, 12, and 9. 7, 14, and 9. 8, 16, and 9. These 5 different triangles are really different, okay? So our conclusion is correct. That is the triangle inequality, how I set up inequalities, how I solve it, and also the enrichment part, which will be the blue wordings, which I have circled in green right now. Okay.